Chris Folgers. August 12, 2023. Share. The Folgers Theory. A fractal holographic illusion. Abstract. This paper aims to comprehensively review the new fractal holographic theory proposed by Chris Folgers in their article, The Folgers Theory in fractal holographische Illusie. The theory combines aspects of the Folgers theory of everything and the fractal theory of matter to propose reality is a holographic projection of complex dimensional information onto a multidimensional magnetic field. It specifically suggests Earth is a neutron particle and celestial bodies like the Sun and Moon are down quarks at different scales and dimensions. This theory provides a novel perspective on the nature of physical reality and makes testable claims worthy of evaluation. The current review systematically analyzes the key elements of the theory, including its mathematical foundations using complex numbers, projections via exponential functions, and interpretations through Fourier transforms. Both the potential insights and challenges of the theory are considered, and comparisons are drawn to established theories like string theory and loop quantum gravity. The falsifiability of the theory's predictions regarding properties of major astronomical bodies is also assessed. This comprehensive review aims to rigorously evaluate the merits and limitations of this intriguing new proposal for a holistic theory of everything. Introduction. The search for a unified theory of everything that can coherently explain all physical phenomena within a single mathematical framework remains one of the greatest ambitions and challenges of modern physics. While theories like string theory, loop quantum gravity, and the holographic principle have made strides, none have achieved full empirical verification or conceptual satisfaction. Into this landscape emerges an unconventional new theory proposed by Chris Folgers, a hybrid model combining the Folgers theory of magnetic interactions and the fractal theory of matter's substructure. According to this proposal, observed reality is in fact a fractal holographic illusion projected from complex dimensional information embedded in a multidimensional magnetic field. By describing fundamental particles and forces via complex numbers, exponential functions, and Fourier transforms, the theory seeks to overhaul our understanding of reality's most essential nature. This ambitious new perspective warrants close scrutiny. The current review aims to thoroughly analyze both the promise and pitfalls of Folgers' provocative ideas. Special attention will be paid to the theory's mathematical and physical foundations, examples of its application, testable predictions, and points of resemblance and divergence with established theoretical frameworks. A rigorous, balanced appraisal is conducted to discern what enlightening insights, if any, this novel approach offers, as well as what difficulties remain for it to mature into a viable description of nature's inner workings. Method. Mathematical foundations. The mathematical basis of the theory begins with the use of complex numbers to describe fundamental particles. Complex numbers consist of real and imaginary parts, written as a plus bi, where I is the imaginary unit satisfying I squared equals -1. They can represent points in a two-dimensional complex plane, with the real part A on the horizontal x-axis and imaginary part B on the vertical y-axis. The theory proposes that each particle is represented by a single complex number that determines its properties. The real part A specifies the particle's quark charge, while the imaginary part B specifies its magnetic field. The modulus, z, equals square root, a squared plus b squared, gives the size of the particle's black hole, and the argument arg, z, equals 10-1, b/a, gives its dimension. Projecting particles onto the field. It is posited that particles are projected onto the multidimensional magnetic field via complex exponential functions. For a particle z described by the complex number z equals a plus bi, its projection is given by the function f z equals e caret cx. Here, the complex variable x represents the particle's position in the field. Its velocity is given by the derivative d/dxf z equals z caret cx. Rotations are represented by if z equals e caret I zx, and the scale by the logarithm ln Fz equals Zx. Interpreting through perception. Particles are then interpreted through perception/projection via complex Fourier transforms. If the projection function is Fz equals E caret Cx, its Fourier transform is Ffz equals A cos x plus B sin x. Here, the real part A cos x encodes shape and the imaginary part B sin x encodes color. The modulus Fz gives temperature, and the argument arg Fz gives brightness. Examples and comparisons. The theory applies these formulae to examples like Earth, Sun, Moon. Earth is represented by the complex number 0 plus 31i, indicating its charge, field, black hole size, and dimension. Comparisons are drawn to string theory, loop quantum gravity, and the holographic principle, noting both resemblances like the use of lower dimensional objects, and differences in dimensionality and background structure assumptions. Overall, the theory aims to provide a unifying mathematical language to describe all phenomena via complex embeddings in a fundamental magnetic field context. Its foundations in numbers, functions, and transforms seek a formulation both conceptually elegant and concordant with physical reasoning. Here is an overview of the improved Folgers formulas that could form the basis for future thesis attempts. Complex particle space C equals A plus by C epsilon C. Properties as functions F1 Z equals A, charge, F2 Z equals B, magnetic field, F3 Z equals